So a warm good morning to all of you from the Department of Electrical and Electronics Engineering, Gayatri Vidya Parishad, College of Engineering, Autonomous, Visakhapatnam. So I am welcoming all of you to the day 5 sessions of ATAL FDP IISGT 21. Today's eminent speaker is Dr. Nilanjan. Sir has joined our sessions now. So I'm just requesting my colleague Mrs. Harijarani Madam to introduce her that we can start the session. Ma'am, it's over to you.
Okay, thank you. A very good morning to you all and welcome to the 5th day 12th session of ACT sponsored FTP on IoT interface smart grid technology. I am K. Harijarani, an assistant professor EEE department, and have the immense pleasure and privilege in introducing our guest of honor, Professor Nilanjan Garu, on this day of 13th August 2021. Nilanjan is an associate professor in Department of Computer Science and Engineering, JAS University, Kolkata. He is a visiting fellow of Department of Biomedical Engineering, University of Leiden, UK, and visiting professor of Yudan University, Vietnam. He was an honorary visiting scientist at Global Biomedical Technologies Incorporated, California, USA. He is a research scientist of Laboratory of Applied Mathematical Modeling in Human Physiology, Territorial Organization of Scientific and Engineering Union, Bulgaria. He is an affiliated member of Signal Processing and Computational Intelligence Applied to Power Systems Research Group, Federal University of USD of Brazil. He was awarded his PhD from Jadavpur University in 2015. In addition, recently he was awarded as one among the top 10 most published academics in the field of computer science in India during Faculty Research Awards organized by Career 360 at New Delhi. Before he joined JS University, he was assistant professor of JS College of Engineering and Bengal College of Engineering and Technology at Techno International, Newtown. He has authored more than 85 books with Elsevier, Riley, CRC Press, and Springer, and published more than 300 papers. His H index is 51 with more than 10,000 citations. He is the editor-in-chief of International Journal of Ambient Computing and Intelligence, co-editor-in-chief of International Journal of Synthetic Emotions, and International Journal of Natural Computing Research. His main research interests include medical imaging, machine learning, computer-aided diagnosis, as well as data mining. He has been on program committees of over 100 international conferences, a workshop organizer of 15 workshops, and acted as a program co-chair of more than 15 international conferences. He has given more than 60 invited lectures in 10 countries, including many invited talks at international conferences such as ITITS 2017, organized at China, TIMEC 2017 at Egypt, and Biocom 2018 in UK. In today's session, we would like to discuss on artificial intelligence in risk management. We are very lucky to have you here, sir. Thank you very much for giving me this opportunity. Now I request Nilanjan sir to address the gathering. Thank you.
Thank you, ma'am, for this long bio. A very good morning to everyone. My screen is visible, correct?
Yes, visible, sir.
Okay, fine. A very good morning to all of you. Today, I am going to talk about risk management and how artificial intelligence can be deployed on risk management. Now, traditionally, we generally used to talk about risk management, but nowadays there is shift from risk management to risk enable performance management system. And we actually try to always find out the emerging risk rather than, the current risk which we are facing. So that the potential risk, if you're able to know prior to any kind of risk facing the challenges, then it will be easier for us to plan how to deal with that risk. So that's why we not nowadays more talk about risk management, rather we talk about risk-enabled performance management. Now the data availability is limitless today as per the technological growth. The devices are getting smarter and sharper, and the business dynamics are more challenging, ever before. So with the increasing complexity and the speed of the changes, and to deal with the risk, potential risk for the strategic planning and long-term success of any organization, we need to come up with some RPMS system. Now, the risk management, once we talk about individual risk management, traditional framework, that generally focus on the preliminary subjectivity and individual perspective. It's not as a whole, as a kind of optimal way to deal with the potential risk, not like that. But always our target should be to find out an optimal way to deal with the emerging risk. So that's why REPM comes into the picture. Actually, it helps the business different stakeholders to identify the emerging risk trends based on some metrics. Now, those metrics are very much effective for any kind of monitoring. Now, what are those risk metrics? There are some any kind of small business. There are some small kind of risks which are associated with that particular business, and these risk matrices actually helps to find out the potential risk. Now, to deal with such type of risk, we need to understand two things. One is the likelihood, one is the impact. Now, the risk likelihood are categorized into three different categories. One is called the probable risk, one is called the possible risk, one is called the improbable risk. So, very likely to happen, and another one is some chance of happening, and there is a small chance of happening, improbable kind of risk. And the impact is also can be divided into four different categories. One is called the acceptable risk for any business. A little bit of risk is there, which can be accepted in any kind of business. Second is tolerable, means which is not serious to the business. Third one is unacceptable, this kind of risk. So it actually causes major disruption to the business. And the last category is the intolerable. So that kind of risk actually leads the business into a deadlock state. So that's why business may not recover from there. So such type of risk is very much vulnerable for any kind of business. So once you know the potential, the likelihood and the impact of any kind of risk, then we can come up with some matrices. And that matrix actually tells you the likelihood, the probable, possible and improbable risk. That is the risk will actually occur, or this likely to occur, or this unlikely to occur. And the impact is also acceptable, tolerable and all these four. And you can see if the acceptable is a very little bit of impact is there, and likelihood is improbable or say possible, it's a kind of green zone. So your business is in the safe state. But once it goes to the intolerable state, and if there is a chances or there is a probable, so possible and probable, so it's a kind of your business is entering into the deadlock state. So from this particular matrix, impact and likelihood, you can understand in which particular stage your business is and what are the different kinds of risks they are going to face in future or how they can cope up with. Now, there is another matrix which is called the consequence and likelihood matrix. So likelihood can be rare, it can be unlikely, it can be likely, it can be almost certain kind of. So consequence is also low, medium, high. So it's in like scale. So it's starting from say 3, 4, 5, total 5 rank, 0 to 5 rank. Now once you look into this, you will see the one type of risk is that the consequence is very extreme or very high, and the likelihood is almost likely and almost certain. So you need a continuous monitoring, and this continuous review process. So once you do for the continuous review, then after that the second category, when the consequence is extreme and very high, but the risk is maybe likely, rare or unlikely. So that time continuous monitoring required, not a kind of continuous review. And if it is a say medium or low kind of consequences, it's a rare and likely, so it needs some periodic monitoring. And if it is low and medium, if it's almost certain, then you need a periodic review. So this is you need to understand that continuous review and periodic review is a kind of review which actually are based on the consequences, what type of consequences your business is facing. So it's a kind of reactive to proactive selection. So kind of the time shifting from one particular periodic to a continuous domain. So you are giving a continuous looking into the business or a periodic monitoring you are doing. So this actually tells you by the likelihood and consequence matrix, which type of monitoring you require or review you require for your business. The third category of matrix is a kind of the appropriateness and the compliance. So once these both are low, that means it's a kind of appropriateness and compliance is less. But once the compliance is very high, and you can say the appropriateness is also high, your business is going in a proper direction. Otherwise, it may happen you need re-engineering the people or you need re-engineering the process. So these are two phases which is actually the appropriateness is high and the compliance is low, or the compliance is high and the appropriateness is low in these two different stages. So this is basically the outcome. So these are the typically few of the risk metrics by which you can understand that which current state your business is standing. So the data analysis actually takes a leading part in risk management. So to identify, to mitigate, to monitor every time, this risk management takes a leading data analysis part. It's a leading part, you can say. So that's why we always try to not only try to reduce, sometimes we accept the risk, sometimes we avoid the risk. If it is not avoidable, might we transfer the risk. So the risk transfer is also very important. Now, how can you identify potential risk? See, there are two different types of risk. So one type of risk is an internal risk, one type of risk is the external kind of risk. So internal risk might be the lack of funding, might be the control, the process, the business portfolio, etc. Or the external, the environmental kind of risk, the political issues are there, or the climatic changes are there. So you need to regularize all those things. So these are the two different potential risks, one internal and one external. And all these type of risk, if you want to identify, then only the industry or the economics around the world, it's become, as it is a very bigger and very complex, you can understand the exact scenario. So for that, what we need, we have to go for one particular technique, which is called a scrapping technique, wave scrapping. And from wave scrapping, we need to go for data integration, the tools you need, which is actually helps to analyze the data. Now, what is basically the wave scrapping? There are huge data which comes in different sources. It might be from the search engine, it might be from any kind of feeding, social media, RSS, the feed, or say any kind of HTML pages, or any kind of real-time data, or maybe sensor data, etc. So from everywhere, you are trying to, even if it's an IoT platform you are using, so from that area, you are trying to capture all those wave and data. That is the wave scrap method. So that is the velocity and the volume and the variety of the data will be a lot. So once you have lots of data, which actually is to talk so-called big data, actually it helps to integrate the internal and external, all those possible data points which are kind of emerging the risk point. So that's why different scenario, different case studies, if you're able to collect from the wave, all those are helps to identify the potential risk. So those are the points, internal and external points. So in this way, wave scrap takes a leading role to identify the potential risk. First phase. Second is, once you're able to understand that these are the identified risks, then you need to go for assessment, you need to go for prioritization. So once you have all those response risks, the availability associated with strategic risk, that need to be understood. So that is maybe the fundamental risk or any kind of, say, operational, which is called, or otherwise it's a functional kind of level risk. So these need to be understand what type of risk it is. And then after that, you have to identify which particular risk you want to give how much priority. And that priority, you should decide based on those metrics, which I already discussed, that three matrices. So from that likelihood or impact matrix, you understand that these particular risks, I need to give that much emphasis, that much priority. So that is the very first phase. Once you identify, then you go for assessment, then you go for prioritization that particular risk. So this can be done by integration tool, data integration tool. Various structured data modeling tools are also available, which actually helps to visualize the whole picture. That in this way, you can this particular risk can be prioritized. It will be a high priority risk, or this will be a low priority risk, so that you can deal accordingly in future. Then coming to the risk response and mitigation, means once you're able to identify a particular risk, you should have different strategies so that you can overcome that particular risk. So it's not a single path that by which you can resolve that particular risk. It's not like that. You have different alternates. Or even if you have multiple alternate paths, so you always try to go for the best selection. So based suitable alternative selection based on any kind of risk as a response, once you try to mitigate, then the selected path is very important. So in such cases, various types of optimization algorithms can be defined. So once you go for any heuristic algorithm or meta heuristic algorithm for selection of the best path, so that the risk, which particular response path you will follow, so that can be determined like that. So this is one thing, to track and monitor the response effectively and a time wave factor. But the thing is, once you not face a particular risk, your business never encountered such type of risk, then how you understand or how you create with data. So that's why we need to create such kind of scenario, which is basically a synthetic scenario, which is called what if this scenario happens. So your the risk model never suggests such kind of scenario, but actually you are trying to simulate if this kind of risk occurs in my small business, then if this, then what? So what if scenario needs to be incorporated. So various risk modeling techniques need to be adopted by simulating that thing. So it's a what if scenario needs to be come up with, so that you can find out that this is the most optimal way to respond to that strategy. So what I'm saying is, suppose there are say multiple scenarios you have already created, and amongst those scenarios you are trying to, like a simulation is created. Now you have to select the optimal one. So you come up with some optimization technique, maybe heuristic or meta heuristic or whatever technique, and after that you select the best scenario, and that possible scenario, how you are resolving, what will be your response. That is the interesting part that needs to be identified. So this comes the risk response and mitigation part. Then after, once you respond, then comes the mitigation. It tracks to implement the effectiveness mitigation plan. So you should have a revisit or refocus that strategy. So otherwise, a particular alarm for the mitigation order will not go. That's why a particular response, once you try to respond, you have to revisit or focus on that particular response. So in this way, you can mitigate that risk. So here actually AI and ML we used to deploy. Basically scenario creation, and after that the selection of the optimization path and all this can be done by machine learning models. Then comes the monitoring part. So timely monitoring is a very important thing, very crucial for this traditional risk management. So if you don't have understanding of potential risk in future or emerging risk in future, then once you face that particular risk, which is basically typically you can say traditional risk management, that time the monitoring is very important. It should be periodic monitoring, or it should be a review kind of monitoring, or it is a complete what type of continuous monitoring you are doing. So that needs to be understood, what type of monitoring you require for your business. So that actually measures the trend or the movement of data parameters. So what are the different parameters? Every risk there are associated variables, parameters. So those parameters need to be tuned. And if you tune those parameters, the risk factor will automatically getting either increase or otherwise it will decrease. So the thing is, suppose there is a risk say R, and that R having a different parameters, say P1 to Pn through N. So all those risk parameters, if you tune by either you increase the value or decrease the value, ultimately once it is optimized, you will get a such kind of risk. It is a very risk factor. So that's why the monitoring is important, but tuning needs to be done. And this is another optimization technique. How can you tune those parameters so that the risk factor will be getting lesser? So it may be both lead or lagging the indicators, but ultimately the end goal is it should minimize the risk factor of the business. So in this way, here one other area, risk monitoring, where AI can be deployed or the risk analytics can be useful for this purpose. So how it actually looks like the risk management, any kind of industry where risk management need to be understand. The very first thing is the risk management planning you have. So that is decide how. Then the second step is the risk identification. This is basically find out them what are the potential risks. Then third one is the qualitative risk analysis. That is basically filtering. You have to filter that this is the priority, high priority or low priority. Then comes the quantitative one. So basically it's the measuring. You are trying to measure that the probable risk is such kind of potential or the quality is high or not. So is this acceptable risk or not? If based on that, yes or no. So if it is no, then it comes the deciding action. So risk response planning, and ultimately your monitoring and control, or otherwise you calculate the responsibility and you get the monitoring and control, and then after that it goes to the management plan. So this is one workflow how risk management for any kind of industry works, any business it works. So it's a kind of generic overview of how the stakeholders deals with those different types of risks. Now the last one, that is the once you have all these things, one can ask the risk reporting. So you need a proper understanding of the life cycle of the risk. Once you know the entire life cycle, then only you can integrate technology to different platform with those individual risk life cycle. So it's a kind of a particular past experience if you are having of say facing those risks, then might be you know how to deal with those, how to schedule, how to on-demand report required. So these all needs actually for data analysis. So if you go for data analytics, you go for data feeding, you go for say any kind of say pre-learning or frozen layer training, you are even for the risk reporting. So these reporting, there are lots of tools. So workflow tools are basically, or analytical tools are also there. Now coming to the second part, that is the potential data can be structured or unstructured both. So it's not the data is always structured data. Organizational data can be unstructured also. And you don't believe that 80% of the data are unstructured data. So it's not follows the RDBMS properties and all. So that's why the digital information collected from the public sources, and somehow the data which has to be directly obtained from the customer. So whenever you are collecting the data, majority of the data you are collecting are kind of unstructured data. And once you deal with those kind of velocity, veracity, and the volumetric data, huge data, then what you need sophisticated tool for to deal with that. And data will significant, or data can be fuel for any kind of as measuring, any kind of planning or strategic planning. So that's why let's a little bit of machine learning. So one part is any kind of machine learning algorithm is very much depends on or very much sensitive to the data which you are using for the training. Like what I'm saying is, for the training purpose, for any kind of training purpose, whatever the data you are using, that data, if you are giving a wrong data, bad data, ultimately it will be negatively impacted the machine learning algorithms. So if you give garbage as in, you will get ultimately garbage. So always our target should be to train your machine with a good data. Now good data is always not possible, because most of the data which we acquire from any kind of devices or sensors, the data are very much noisy. So the data initially needs to pass through a cleaning process. So data cleaning process actually identifies the correction goes for the correction process of the data, where so that the entire model is not impacted by the negative, impacted by the bad data. Now the bad data is nothing but the inconsistent schema. Missing data is there, redundant data is there, the contextual garbage values are there. So all these are different noisy kind of data, perturbated data, and these are called the bad data. Now there is a quotation which is called all good data are alike. So good data, whatever you are generating or creating or you are grabbing or capturing, all good data are good enough for any kind of training. But each bad data is bad in its own way. Each and every bad data, once you are dealing with, that bad data needs to be properly, you need to tune, you need to go for a proper treatment, cleaning process. Otherwise, it will be, end of the day, negatively impacted. So it's a kind of outliers, you can say. So that's why once we have a lots of data generating from any kind of system, it may be any kind of system, which we need to understand that the data is always fine, the velocity, and the volume is always fine. But we need to understand that if the data is a bad data, ultimately it negatively impacts the machine learning algorithms. And end of the day, whatever the result you are getting is not the correct result. So that's why we always need to go for a cleaning mechanism, which actually helps to identify all those data, that these are the bad data, these are the good data, and bad data needs cleaning process. Okay, so now the second question is how much data we need. Hello? Yeah, how much data actually we need, because data is a fuel. Now, once the data is a fuel, we should have some heuristic technique, which will actually determine that any kind of system, this much of data generation is required minimum. But ultimately, end of the day, as much clean data you are able to collect, that is good enough. The answer is as much as possible you try to collect the clean data. Now think from other point of view. Suppose there is a single point, and if you are trying to fit a polynomial curve, then the generation will be not very good. But if the number of points increases, the generation will be better. And if the number of points are more number, then ultimately you will see you can fit a very fine curve. So the generation of this curve fitting will be, more generalized once the number of data points increases. Similarly, in linear regression, suppose there are few numbers you are generating, few data points you are generating. You are trying to fit a particular straight line. You will see ultimately the regression is not maybe not proper. The point estimation is not good. So what you need, you have to interpolate more number of points, or if you come up with more number of points. So if you have more number of points, the point estimation will be much more better. So from any other, say any kind of KNN plus N plus when you go for, or say partitioning hierarchical structure, more number of data always gives you a more generic. So any system point of view also, whenever you create more number of data, the analysis part will be much more better. The generation part will be much more better. So here also, for the learning purpose also, if you are able to grab more number of data, that actually helps end of the day, if you are able to clean those properly, end of the day you will get more generalized result. Okay, so now the question is, what's wrong with small data? It might happen that in various kinds of research area, you will see, end of the day, we don't able to gather more data. We have very less data. So if you have very less data, how can you analyze? If you have very less amount of data, how can you increase the data? That is another point. So what I'm saying is, suppose end of the day, you need say 5,000 data, but ultimately you end up with 500. So if you have 500 data, how can I go for? So see, simple, think about it, that there are 2 points and I'm trying to draw a straight line in between these 2 points. Now, how can you increase more number of points? You can go for interpolation. You try to interpolate say 1,000 numbers, 1,000 points within those 2 points. So in this way, it will be more generalized. So from those 2 points, if you come up with more generalized ones, you can interpolate. Interpolation can be a solution. So the first try to understand that what the problem with small data. If the data size which I am getting as a result is less in size. And the second part is, if the data size is less, how can I cope up with? How can I increase the number of data? These are the 2 things need to be understood. One thing is, if the data size is very less, the variance of the data will always be very high and it will roam around. So it will revolve within a high variance because the size of the data is very less. Second thing is, within a small data set, there is a high chance the outlier should be there. So if you have 5 data, 1 outlier, 5,000 data, 1 outlier, you can think that if it within 5 data is 1 outlier, how dangerous it is. That another thing is the overfitting. Most of the machine learning algorithm getting overfitted if the data size is 5. So if you train with say 5 or 5,000 data, you will get 100% accuracy. But that doesn't make any sense because it is overfitted result. So you have to come up with more number of data. And another thing is the last one. Most of the cases, whatever the data we try to acquire are noisy data, quarter-weighted data, and few data. So that's why If noise data or all data is also very dangerous, because if you have say 100 data and most of the data are corrupted data, noisy data, then whatever the result you are getting. Hello, is it? Am I audible?
Clearly audible, sir.
Okay, fine. So that's at the time it's not possible. When it's a noisy data, how can you deal? Now another part is, as I said, that you can deploy these techniques in any kind of field. I'm talking about risk management, but not only risk management, in electrical engineering, mechanical engineering, any places. If you are dealing with data, you have to sometimes increase the number of data. If you are dealing and generating a small number of data, how can you increase the more number of data? So one way I can show you, that is called the using of data augmentation technique. You are trying to increase more number of data by using a sophisticated technique which is called GAN, which comes in 2015. Now this is one typical example I am giving. Suppose the scenario is like that I am trying to acquire a new customer, but the customers are very much unknown to me. Means I don't know who are the potential buyers or the sellers or their behavior. But I try to map with that. I try to augment that what type of data can be. So I have a very less data, but I am trying to create more number of data for more better generalization. So what I'm saying is, if any kind of scenario occurs, whatever the result you are getting, a very less number of data you are generating, but ultimately the end goal is to come up with a robust system, to come up with a more generic system. How can you increase your number of data points? So this is one technique which is called GAN. By using this technique, you can augment the data and in a very sophisticated way. Let me give this example as from an image point of view, so that ultimately the visual representation you can understand, so that you can deploy it any kind of data generation. So I'm not talking about only risk management, any kind of scenario. If the data number is generated data is less, how can I increase more number of data for my system to make it more robust, more generic, so that the efficacy and the effectiveness of the system can be ultimately proved as a good one. So let's think about this, that suppose this is one latent space where we are actually dealing with some noise, and the noise is Z. This Z is a uniform or any kind of normal distribution noise. So this is a noise space, and what I'm trying to do from that noise, I'm creating a fake image. Say an image of a fake apple. I'm creating a fake apple, which is not actually an apple, which is basically created from the noise, and the noise is a Z. Now once it passes through the generator creates a fake image. So then the apple is basically nothing but noise. Now it's created a completely looks like an apple, and it is a fake image. Now once Z passes through the G, it creates X. So X is the fake image. Now X is compared with the real data. I have a pool of real apples, lots of different types of apple data set I am having. Now I am comparing these two apples. So discriminator is the second part. What discriminator is doing? Discriminator is trying to identify the data which is sent by the generator is a fake data or is a real data. Now until it is able to identify it is a fake data, that means the data generation is not proper. But once it not be able to identify that this is a fake data, that means your synthetic data generation is correct. So you are able to create synthetic data, realistic data. So our objective is that generator should create more and more realistic data, and the discriminator will try to fail to identify that this data sent from the generator is a fake data. So what I'm saying is the generator creates fake data from the noise pool, and the second part, that is discriminator, always try to identify that the data which is sent to the generator is a fake data. So it tells the probability 1 and 0 that the data is fake data or it's a real data. Is it a real apple or it's a fake apple generated from the noise? So the generator always, it's a kind of the tussle in between the discriminator and the generator. Ultimately what happens, see, generator we pass the noise Z, there is a theta 1 tuning factor, it passes to the generator, it creates an apple image which is X. Now X passed to the discriminator, there is tuning theta 2, and the discriminator decides with the probability that the data sent by the generator is 1 or 0. It's a fake data or not fake data. Now in this way, what happens? We try to maximize and minimize two things. What we try to maximize? We maximize the real data X needs to be classified as real data, and the fake data, it should not go to the real data pool. That means one, we are trying to maximize the real data go to the real data pool. We try to maximize it, and what we try to minimize, we always try to minimize that the fake data should not go to the real data set. So it's a max min problem. The real data goes to real data, and the fake data should not go to the real data. In this way, it's a kind of max min problem. Now this maximization minimization problem, what actually doing? That discriminator ultimately trying to classify that the image is fake or not fake. So always there is a loss function associated with the discriminator, because discriminator is working as a classifier. So there is a loss function. Now think about it. Any classifier, if the loss function is something like this, that if you do any kind of error, you have to give high penalty, then automatically the chances of doing error will be lesser, because less error gives high penalty. That is not always acceptable for any system. So that's why we use logarithm function, so that we can determine that if you do any kind of error, the discriminator need to be give high penalty. So in this way, there is an objective function which functions determine the max min one, so that ultimately after several iterations, after several training purpose, one point reach where generator not be able to create more synthetic data, and the discriminator failed to identify that the data is fake data, and it stops. In this way, we create data which data is not actually there. It's a entirely synthetic data which is created. And in this way, the loss function is actually given by the Nash equation from game theory. But the notion is, what I'm trying to tell, that any kind of system, not only risk management, for any kind of system, once we have a very less number of data, we try to create our own data by data augmentation technique. One of the sophisticated technique, very recent technique, is called the GAN. By using GAN, what you can create, if you have a very less size of data, and maybe you are trying to deploy machine learning algorithms, you failed. So that time, if you want to increase more data, you can create your own synthetic data by one of these techniques. There are several other techniques like neural trial transfer is there, etc., etc. But one technique by which data can be generated or can be augmented. But why I'm talking about this? I'm talking about this because the reason is I was trying to identify the potential buyer or the customer who are actually helping us to decide the risk factor of my business. Who will be the potential risk factor? Means what will be the buyers and the customer. So I don't know who are going to buy or who are going to the customer. But I can simulate, I can augment, I can create my own data, so that what if scenario I'm able to create, I can respond those risks based on that. I can strategize, I can plan my risk in that way. So that is the notion of using the data augmentation. So I think I have few more time. Yes. Okay. So second part is, as I said last time, that as putting various from various points we are gathering the data. Always, if you have a big data, there are various types of factors associated with that, which negatively impact the business. First is the financial risk. Second is the cyber security or the cyber attack. Third risk, which is associated with the prediction model. Whatever the different scenario your business is going to encounter in future. So the simulation is important. The characteristic, understand the simulation is also important. So if you see into any kind of business risk, you will see most of the major risks are associated with data. So any company's sales or any lower cost of staffing, any places is always related to the risk factor, mostly related with associated data. So that's why data plays an important role in the strategizing planning. So what are the different risks? A very short period I'm trying to give this discussion. One is the potential identifying the frauds, which is very common, and everyone knows that once we are using some kind of transaction we used to face these things, very risk factors associated with that. This is the online transaction cases, one scenario where the identifying the fraud. Second is the financial risk. Say if you are giving a credit to a particular customer, a new customer, but you don't know or don't understand the behavior of the customer. So will you give the product, say on delivery kind of thing? So you need to understand that if I give this product, he will be after delivery, he will be able to give me back the money or not. So what I'm saying is the full payment before delivery of a product or service on credit, that is always a risk factor. So you are giving the product, you are sending that product, and ultimately you see that you are not capable to give that money. So that's why we need to identify the financial risk management actually tells you that whenever there is a new such type of scenario occurs, what are the risks associated with that. Then comes the attrition risk. Like you are giving a training for a particular organization, ultimately you will see most of the people after getting a job interview process and the training, they left the company. So that's why human resource part is mainly focused on this area where they try to reduce the employee attrition, which is also a risk for a particular business. Then comes the operational risk assessment. It's a kind of bigger risk, you can say, a strategic risk, and the big data actually allows to identify all kinds of different risk parts. So these are not only for a particular business. I'm talking about the generic business scenario where any kind of engineering are is a kind of heart of that thing. Then comes the digital risk, where the average costing or the data breaching is very important. It's a very vulnerable one. We have to mitigate that risk. That's the digital risk. And the last one is a very low graded risk. Suppose you want to open a retail or say restaurant chain in a particular location. So what you need, you have to understand the demographics of that particular area, the population of the data, the density of, or the say you can say the behavior or the potential customer behavior pattern you have to identify, so that you can find out that this will be the next potential location where I can start my venture. So that's why such type of risks are also associated with business. So these are the few examples, but there are lots of other risks associated with this. Now, as I said, I was talking about artificial intelligence. So it actually improves the productivity, the profitability, and any kind of business result. But how it actually helps us? The first thing is, once we try to deploy artificial intelligence in any kind of business framework, the major concern is the you can say the inconsistency or poor data collection. Because whatever the data you are trying to gather, maybe most of the cases, as I said, noisy data. Second thing is the skill shortage. Any kind of traditional workers or laborers who are heavy laborers who are associated with any kind of industry, they are not that much indulged to adopting the technologies. They are having skill shortage. So technical staff with experience and proper training there is always lacking. And you can see once there is an adaptation of AI technology, the main thing is you need it always relates to the cost. So if you are coming with some ERP system, or if you are going for any kind of adopting new AI technology, smart technology, it always deals with the associated with the cost, infrastructure cost is there. So if you don't have in-house skill, it's always not always to jump for AI immediately. So the complex nature that smart technologies as it is coming, so maybe the cost, the repairing is also, everything is there, but ultimately end of the day we have to adopt for AI technology. But why that is a thing which I am going to talk about. So there are limitations of adaptation of AI technologies. One is the say time challenges or the integration challenges or usability challenges. But privacy is also a major concern. There is a lack of transparency, etc. So let's talk about industrialization, Industry 4.0. See, actually it starts from 1780, where the machinery comes into the picture. So it was Industry 1.0. So industrial production based on the machines or the power systems. It's driven by the water and the stream. Then after almost 90 years later, electrification comes. It is Industrial 2.0. 3.0, basically we are moving or shifting. It's a paradigm shift. After 100 years of electrification, automation comes into the picture. We immediately say within say you can say 10 years, 3.5 comes. That is basically the globalization. So you can grid. So once you're at low cost economical countries, they are adopted various type of production techniques. Then 4, that is the today's. That is, we are mostly on into the digitalized form, and we are trying to adopting artificial intelligence technique, technologies, etc. And we are incorporating into the business. And we are looking for 5.0 and 30. So what is our target? Our target is the human intervention also should be there. It's not only the cyber physical system. So initially we start with machineries, then we go for mass production. Then after electrification, it comes the automation, globalization, and now we are belonging to the cyber physical system. But what next? The next is 5.0. We are planning for mass production along with the help of cyber physical system, but there should be human intervention. So it's not only robot, rather you are actually think about say human robot. So it's a kind of humanized computation with the help of AI. Now this is our target for industrial 5.0. Now if you think from the society point of view, the society 1.0 was the hunting, society 2 was the agriculture, society 3 was industrialization, 4 was the information security, and the security was also there, and 5 is the society. So similarly, in the same part, the light industry, heavy industry, automation industry, and the digital transformation, this all goes in the same channel. So we'll have to say for example, here in the 4th revolution, we are standing here, and we are targeting for the 5th one. So society and the industrialization both is going in the same way. It's a parallel path. Now, once we talk about ML in Industry 4.0, what we talk about? We talk about industrial IoT. There will be industrial IoT, and this is the say cloud infrastructure. Maybe it can be fog, it can be node, it can be edge devices, and this is the ML part where you are going for the fault detection, or going for the predictive model maintenance, etc. But human interaction is also there. Ultimately, the society is also there. So all these comes into the fault prediction and the action selection. So this is our current state, but our intention is we have to come up with cobots. So it's a collaborative robots. It's not only the robots, rather we will target in 5 the cobots, that is the collaborative robots. So industrial 4.0 are getting faster and smarter adaptation, and we have to embrace this technique. Otherwise, later onwards, we can't cope up with the transformation. So the present scenario challenges and the risks which are associated with the business in 4.0, we have to embrace AI. There are few barriers in digital transformation. One barrier is as I said, the lack of skill and the training of the industrial 4.0 adopting the industry. Second thing is the concerning, there is always the factor of security factors. There is a capital expenditure which is associated with the business. That is a big factor. Lack of appropriate digital infrastructure, that is another factor. And lastly, lack of knowledge. These are all different barriers. So you can see this is the 4.1, this is the 5.1. In 4, this is adaptive manufacturing techniques, sensor devices, big data, robots, IoT, clouds, cyber physical systems, all are interlinked. But in 5, what happened? There is a 5G. So the network part is also important. Apart from these, the intelligent materials, intelligent devices, intelligent system and automation also comes into the one picture. And as I said, the collaborative robots plays a significant role. So in future, it will not be only the robots, rather it will be a collaborative robot, where human intervention will be here. So we are targeting for 5.0, where the robots will play a significant role. From ethical point of view, there are some concerns. Like one is there is a high chance of job loss. So we need to think about the redeploy and training of the employees. So first, distribution of the wealth. Then once it goes for the machine interaction, always there are different challenges and issues that come into the picture. The security concern is a big factor, and the devices are getting smarter. So we have to think about the ethical issues of AI associated with that. Once we try to deploy in any kind of heavy industry. This is a few of the example where people actually try to adopt this kind of technique. Like this is one BMW factory in Oxford. There were initially 1,000 say built-in order cards they try to produce every day, and there was actually 4,000 employees and entirely driven by robots. There are a few robots, but most of them are robots. So if you go from here, you will see there is no person standing over there. There are very few person. But end of the day, once the quality part comes, it's all manual. But remaining everywhere, it's all robots. So we are moving towards that direction, but it should be human intervention should be there. So they are producing say 2.5, 2.2 lakh that time, but now the employees number I think it's I'm talking about 2 years back when I last time. So I think now it is around 1,000 employees. So 1,000 employees per day they are generating this much number of built-in products, complete built-in products per day. So this one is another example. Which is also very surprising that there is a company Kansai in China who are actually the manufacturer of shoe. So in their company there was almost 250 intermediate steps where they start. I mean, it captures from the sensors and it will show the 3D diagram of your feet and it will recommend what type of shoe you can go for. And after that, once you choose that one, then it will end product will be it will give you that kind of shoe. There are 250 almost intermediate steps, 80 plus almost. So all those steps starting from the 3D scanner. So you can't imagine this majority, maybe 70 to 80% of those intermediates that are human driven. It's not automated. So as I said, one part I'm showing that entire robotics is robotic driven. Another part where humans are deeply involved into this kind of work. And maybe ultimately, say 20 minutes later, I first got that shoe in my hand. So it was a surprising thing that almost 200 intermediate steps, but most of the cases, all the human interventions are there. So we are not actually going or discarding the human. Rather, we are trying to give a human incorporation into the smart system. So these are all in this step, as I said, they are working on this. So last slide. So what we are trying to do from level 1, we had awareness where AI invests in the large. It was a overhype initially, but gradually after the transformational, it's becoming a main part of business. So this talk actually I try to give a generic view in any kind of platform. What will be the risk? What will be the different challenges? How can you identify, mitigate, assess, etc. And how can you report that risk? And finally, how can you cope up with that risk? Maybe by deploying some sort of AI techniques and technologies in this area. Thank you very much. So if you have any questions, I'll be happy to answer.
Putting all the participants, please just raise your hand and post your question in the chat box.
Okay, so if anyone having any questions, please. Sorry.
So any questions from the participants?
Okay, I think no.
Can I ask a question, ma'am?
Yeah.
Okay, so, sir, hi, good morning, sir.
Good
morning. The question is, what kind of AI risks are there involved if we implement the artificial intelligence in a sector like smart health monitoring?
In smart health monitoring, first thing is you are dealing with patient data, which are very much, there are different data protection laws are there. And the data protection laws are different for all different countries. See, for European countries, data protection laws is different, but for other different countries, patient privacy laws are there. So that's why once you are trying to adopting any kind of artificial intelligence, the main challenging factor is the patient, the permissions you need to obtain. Because most of the cases we not able to acquire the permission from the patient. That is the first point. Second point is, once you go for deploying AI, the second factor is the data which you are gathering, you are capturing. Always we are happy with the 100 CT data or X-ray data. So those type of data, they are very less data for any kind of machine learning or other you can say artificial intelligence system. So that's why to deal with a very small data is, as I said, it was also very challenging. And always you have to benchmark your result, your obtained result with the doctor's one, because you can't ignore that community. What you can do, you can give a support to that fraternity. So that's why always we have to work side by side with the doctors. But their support always will not get that much. See, any artificial intelligence gives us some result that needs to be validated with the doctor's test one or the benchmark one. And lastly, the ethical concern is also there. There are some ethical issues which always relates with AI. So those factors need to be taken care for smart health monitoring. And even if you are working for the telemonitoring or any kind of tele, then there are also some security issues also comes into the picture. So these are the few factors which are associated with monitoring, health monitoring, in, you can say once you are going for adopting AI.
Thank you, sir. Sir, another question that I have in my mind is, so in case of if we are looking at a cyber attack, and does localization of hospitals' data is important in your opinion? Do we keep the data in a localized manner?
There are few diseases where we need to trace the data from the very beginning. Like suppose if you have a rheumatic fever at the very childhood, there is a high chance that you have some heart disease, say 30 or 40 years later. So what I'm saying is, suppose I forgot all about that thing, that I had a rheumatic fever at the age of say 4 months. But ultimately after 20 years or 30 years, I become affected by a cardiovascular disease. And then I can, maybe my family members told me that you had a rheumatic fever a long time back at the age of 2 months. So there is always a link with some disease, previous disease might be this particular disease. So that history, that record, we generally not used to keep. We used to go to the doctor's chamber, we used to go for medication, and after the things resolved, we forgot all about that. But if there is some centralized database which actually stored all the electronic patient information from the very beginning, from the day one, maybe you have a card, digital card, like just like blockchain you are using, and that card will tell you the complete patient history. That will be always helpful for you. It should be portable kind of thing. Now coming to your question, that once you do this thing, if you are centrally managing this thing, there are again some countries are there where central database is there, but in our country there is no as such central database of all patients. The main reason is there are some disease which people not wants to share with others. There are some data which people not wants to share. Suppose in my family member there is some disease which I not wants to share with anyone. So that's why, as I said, the root level is the patient consent is most important. The patient is willing to share his data for research or not. So that's why there is a big gap in between. So you can't take and put it into centralized database until you get the permission from the patient.
Thank you, sir. Thank you for your opinion. If you don't mind, can I just ask another question?
Please.
Yes, sir. The thing is, currently we have seen that there is an AI that is being used by some countries for law purposes, and it based on all the previous data, it predicts what kind of penalty or what kind of fine a person has to pay when it when it commits a crime, when he commits a crime. So do you think it's fair for a person who is being given a sentence that is not even being given by a proper judge?
Technology will tell you this you can do, so you will do it or not do it. That depends upon various factors. A particular country will adopt this or not adopt this. That is not their, that is their headache. But technology will always tell you that this you can do. See, cloning is prohibited, but we got Dolly.
Yes.
people tried and they come up with Dolly. So that means it's not that the cloning will stop. It is that you will go for cloning or not, that need to be decided. So here also, once you are talking about law enforcement, let's see, I don't know that who is going to go for, I mean, this particular crime, doing the crime, but I can predict that, see, you take it or not take it, that is depends upon various other factors. But technology will tell you that this can be one path. Are you getting what I'm saying?
Yes, sir. Yes, I get it.
Okay.
Thank you so much, sir.
Thank you.
Another question?
Okay, Pooja madam, I think
there are no other questions. Sir, it is actually it is a great session, great learning about artificial intelligence and security. Because security is the most important thing when we are dealing with the IoT or any applications which is based on the internet connectivity. Because you have to store the information, you have to access the information, and everything will be on the storage only, and that is completely cloud based. And we are dealing with the big data, which is a very huge amount of energy. So your lecture has given us a very good platform of good information regarding particular the security analysis and security issues and how to go to the security of the particular thing with our data. So thank you so much, sir. On behalf of security department,
thank you.
College of Engineering, I'm really just giving my heartful thanks to you that you have just we have so much appreciated you have just accepted our particular request and you just give us for your valuable time. Thank you so much.
Thank
Thank
you.
you, sir.
Stop. So I'm leaving the meeting.
Yes, sir. Thank you. So dear participants, actually we are planning like that. 11:45 again we have a one session. Which is person. So if these all people join 11:30 onwards, so 11:45 start we can start the session. Then follow the lunch break, and after the lunch break at 2:30 p.m. we are planning for the validated function and for the 20 to 25 minutes, and after that we'll share you the question bank. So by 3:30 you people all complete this particular LPD work. So and another thing, this toolbar yesterday and today completely we are considering this particularly attendance is last 2 days. Today and yesterday from the generated WebEx attendance. So no, we are not sharing any further attendance sheets with all of you. So don't worry, we consider all the attendance you are present. If you are logging also, your login account type will be there. So no problem, you are logged in and you are just by any technical glitches if they are disconnected. So we are not going to miss the declaration, we are going to consider everything. So thank you very much. If you have any information or doubts or something, then just raise your questions in the WhatsApp chat box. So the coordinators and I will be there with all people to just keep it all information. Thank you so much. We will start the meet at 11:30 in the next session. Thank you.